Whether you call it the subway, the metro, or the underground, whether you ride it to work every day or once a year on a trip to the big city, this machine has changed the world around you.
If we hadn't won the battle to build the first subway, they would still be scraping horse manure off the cobblestones.
Every truly great city in the world has one of these running below its streets. You want to ride? Under the ground at lightning speed, 1 million people a day. You try it.
Every day, on average, 904,000 people go through those gates, come down these stairs and ride these trains. They don't really think about it. That is until a guy like me gets on with the camera crew, starts asking questions. Where's it come from? How's it work? How fast can it go? Why does the other train always seem to come first? Why does the other train always seem to come first?
I don't know.
Riding the subway may not seem like a big deal to you. It may even seem a little bit, shall we say, boring. But that's because you are a 21st century sophisticated urban dweller and, well, maybe just a teeny bit spoiled. The subway is the result of one of the world's great engineering feats, and it was created by those fun-loving wisecrackers, the British Victorians. By 1843, London had already invented and perfected the traffic jam. They used horses instead of cars, but it was just as effective. One reason was the trains, or lack of them. All the stations were at the edge of town, none of them were connected to each other, and there was nowhere left to put a railway line through the city. Until Charles Pearson, the city solicitor, had the bright idea of building a railway underground.
In the 1850s and 1860s, the streets of London were as crowded really as they are today. So the idea was to dig up the street, put an underground railway in it, cover it over, and then you'd have both the traffic on top and the railway running underneath. And it worked. Nobody had ever built an underground system in a town like this. Indeed, it was really a pioneering thing to do, and it was done with picks and shovels and 2,000 people working often through the night. And really, that's an extraordinary process, and it only took 3 years, whereas today, building a subway line in a major city often takes 7 or 8 years.
In 1863, the tunnels were ready to go, and the first subway train ever rolled through.
Riding the first underground line here in London in 1863 would have been something really different. For a start off, it would have been steam operated, and of course with steam locomotives that meant you had all the problems of atmospheric pollution.
The notion that you'd run steam engines in narrow tunnels, that's a completely crazy idea really. And the chemists did a very good trade outside the underground stations because they used to sell something called metropolitan mixture, which people would come out gasping for air from the kind of steamy, smoky system and buy this metropolitan mixture and hopefully kind of come round.
Today, subway trains, whether you're in London or Toronto, are powered by electricity. The electricity comes from a third rail running alongside the main tracks.
This is our collector shoe. The collector shoe collects the power off of the third rail. It goes into the motors, and if we go underneath, this is our electric motor. The motor drives the drive shaft. The drive shaft drives the gearbox drives the axle, which drives the wheels. And this is our single axle wheel and our brake shoes. The brake shoes are controlled through pneumatics, air power.
Steel wheels on steel rails is okay, but for a nice smooth ride, try rubber. In Montreal, the subway trains run on pneumatic tires.
Because of the grades, we have the major grades from 6 to 7%. And it was the way to go back in '63, and that's where we went. Here in the workshop, the tires don't touch the ground. We process here all the tires we put on the metro. There's about 1,500 tires that we have to mount and dismount every year. And we do inflate the tires with nitrogen. It's like inflating a tire with straight air. It's just that we have to order the nitrogen. We use nitrogen because there's 25% less permeability of the tires, and also it's less combustible than straight oxygen.
Ce qui arrive, c'est que nous autres, on utilise deux types de, si on peut dire, de suspension. On a des pneus porteurs qui servent de suspension primaire. Et puis, on a ce qu'on appelle les roues de sécurité, qui sont en fait des grandes roues de chemin de fer, qui servent à guider la voiture dans le cas où on aurait un pneu dégonflé ou dans les aiguillages.
When the trains go out into the system, the tires take the weight, the safety wheels are lifted up slightly off the rails, and the little wheels at the side guide the train in a concrete channel.
We're at the south end of Greenwood Yard, going to 18 track to get on train 909. Always be aware of your surroundings when you're in the yard because the trains could come at any time from any direction. Okay, we're on a Hawker 6 train, meaning Hawker Siddeley. That's who the maker of the train is. On each car, we have staff doors. If the operator wants to get off the train without opening all the doors, they can just open up the staff door using their PAX key. And the operator connects it onto a platform. And to close it, you just do that. So you want to have a look inside the cab. It's your reverser key. We have forward. And we have reverse. So we want to go forward, we don't want to go backwards. To build up this train is you have to push down on the handle, move around to the coast position, and we build our brake pipe. It has to be between 89 and 90 before the brakes are released. And I just heard the click. If I let it go, the air will dump it. So anytime you're going to move a train off, always sound your horn twice. That warns anybody that the train's about to move. We have three different settings on the master controller. We have inch, which is roughly about 10 to 15 kilometers an hour. We have series, which will take you about 30 kilometers an hour. And of course, we have full parallel. And that all depends if you're going up a hill, down a hill, on a flat. Usually when you're on the train and you're going from station to station, you're only doing about 60 kilometers an hour. I know when you're in a tunnel, it seems much faster than that because you're in such a closed environment.
But with so many trains whipping about in the dark, how do you keep them from ramming into each other?
This is the yard control board. Okay, the red lights indicate trains. There's a train moving around the yard now.
There are sections of track that are separated by insulators. When a train passes onto a new block of tracks, the system knows it's there because the metal wheels make an electrical connection with the rails. The drivers know what to do because there are automatic signals on the walls of the tunnels to tell you what's happening on the tracks up ahead. If they turn green, you're good to go. If they turn red, you go faster. No, wait, that doesn't sound right.
Okay, we're going to learn the signal system. As long as the train in front of you moves, those lights are going to change.
Okay.
Because we work on a 3-block system here.
Huh.
The train does not get any closer than three signals from the train in front of it.
Okay.
Okay, so let's just suppose the train in front of us starts to move. You'll see it do that. And what do you think green would mean?
Open her up.
Go. And as long as he keeps moving, those lights will keep changing.
Okay.
Then we have a yellow light. A yellow light is telling us that the next light is going to be red. Be prepared to stop.
So slow down.
Yes.
Let it go green.
Yes. Proceed, prepare to stop at the next signal.
Okay.
Because it's going to be
Green, red.
red. Red light means
Go.
Stop and
Stop
stay.
dead.
You don't go anywhere.
Luckily, if the signal is red and the train goes by anyway, there's a device under the train called the train stop. Guess what that does?
When the trip arm comes up for the track, it'll trip the trip arm and cause the brakes to go on the train. It'll stop the train.
Arriving at Christie Station.
Driving subway trains looks pretty easy though, right? I mean, they go forward and then they stop. How hard could it be? Okay, I think I'm ready. I'm about to enter the TTC subway train simulator to learn to drive.
So have a seat.
Okay. This is like it's like the fun room at a family restaurant or something.
Exactly. All right, so let's pretend that you're a subway yard operator who's going to check this train for service.
SOB.
Yes, SYO.
SYO, my mistake.
No, not that.
Okay.
Flip a toggle switch, take that around.
To where?
All the way around. And when you do that, it's going to go down the train to each car and they're going to check the motors to make sure they're in sequence. And if we get sequence, we will get 2 blue lights.
Okay, with sequence just mean that we're all attached and everything?
Yeah, everything's going. The motors are all in sequence with each other. If this light comes on, one of the motors is not working properly. And we do what we call a line switch reset. You want to push that?
Yes. You made that noise.
No, I didn't.
That's you making the noise.
No, it was not me.
That's you, Bill. I
No, it
can
wasn't
hear
me.
it quite plainly from your mouth.
Something wrong? No. Okay. You want to push it
Your
again,
throat.
please?
I don't. Okay, here we go.
All right.
Bill,
No.
that's you.
No, it wasn't me, honestly.
I can see you doing it.
No, you have to stare at it to do it.
I can see you. Come on.
So we put it back into full brake.
Brake.
Is if you let this go with less than 80% brake, the train will go in emergency. But it's called the dead man, which means that you've passed out or you've died.
Right.
The train
Dead
is going
man.
to stop.
Right.
Yes. There you go.
And then it would
you
stop
fall
like
on
that.
the buttons and on the horns and yes, exactly.
And then avoid.
And then you're done.
Well, the subway was going great guns in North London, but to the south was this big awkward river. Good God, man, how do you put a tunnel under a river?
I'm standing 50 feet above the East London railway line. This is the first tunnel under a river anywhere in the world.
It was Mark Brunel who built the tunnel, along with his son, Isambard Kingdom Brunel, who later became world famous as an engineer, and not just because of his fancy name.
Brunel, father and son, began here by building a 50-foot tower, which is taller than these buildings. Now, locals, of course, thought they were mad. They're French, after all, and they don't know the first thing about engineering, and particularly about tunneling, because whatever language you speak, tunnels are below the ground and not above it. But the trick is, if you want to build below the ground, then you build above the ground and sink it.
See, the thing is, their tower was built on a giant metal ring with a sharp edge, so as they dug the ground out inside it, it sank. Then they had a waterproof shaft 50 feet deep, which is still there. It's now the stairwell down to the trains. Then they could start tunneling across. For that, Mark Brunel had invented something new, the tunneling shield. It was a frame that braced the tunnel walls while the men dug inside it. Each man would remove a wooden brace and dig out 4 inches of dirt, enough for 1 row of bricks. Then they'd move the whole contraption forward 4 inches and do it again. And then do it again. And then do it again.
The distance from this side of the river to the other was, I am telling you, dug in 4-inch strips by men with short-handled spades, showered with raw sewage from the River Thames and dodging tongues of flame which shot from the frame as they came across pockets of methane gas on their excavations. An awful job.
The tunnel opened as a pedestrian walkway. It was a huge tourist attraction, 50,000 visitors on the first day alone. There are 60 archways between the 2 tunnels, and inside the arches, women would set up stalls to sell souvenirs. Tunnel gin flasks, tunnel pincushions, tunnel spectacle cases. If they'd had baseball caps, they would have sold those too. But soon the novelty wore off, and other, different women started conducting business in the tunnel, selling different products. Unlicensed merchandise. Well, that just wasn't going to be tolerated. We are, after all, Victorians. And in 1882, they closed it down and built train tracks through it. 160-odd years after it was built, the Thames Tunnel is still working fine. Today's tunnels are built using the great-great-grandson of Brunel's tunnel shield, the Lovett earth pressure balanced tunnel boring machine.
This machine has got to go from this level, which is quite shallow, under buildings in front of us, down to a depth of 35 metres under the Thames, where the water pressures are 3.5 bar. It then goes up the other side round a 90-degree bend, 300 metres radius, to eventually emerge within the Woolwich Arsenal station. And we're going to be there round about the end of August time. Hopefully a little earlier if we can make the thing go a little bit faster, which is always nice to think we can. This end here revolves, you can see from the cutters on the front. There are some gates inside the head, as you can see. There are holes in the head into which the material is swept as the arm rotates. Behind this wall, this concrete wall, is a full head of water within the ground. As the machine goes through there, it will experience that full head of water. And the seals around the outside, there are two blow-up seals within the metalwork there, which wrap around the machine itself. And as that machine goes in, the water pressure comes around the machine, but it is stopped by those seals. Now we have an erector here. This great hulk of metal here is an erector. It's a vacuum pad erector. Segments are brought in by train. There are 8 segments in every ring. The erector then spins and builds the segments into position around the 360 degrees of the tunnel.
The head of the machine is pressurized so the weight of the water overhead won't force itself into the tunnel. As the dirt is scraped away at the face, a screw draws it out, but only at the exact speed at which it's dug so the pressure doesn't drop. The concrete segments are lifted into place and giant hydraulic rams press against them to force the machine forward bit by bit. The ability to dig tunnels deep below the city without ripping up the streets is what made it possible for London's Underground to become the complex system it is today.
London's Underground almost has 3 separate systems, even though it appears as one 11-line system on the map. First of all, we have the cut and cover, the shallow subways in the centre of the city. Then we have the enormous deep tubes, on average 20 to 30 metres below the surface. But it's worth remembering that the bulk of the Underground, of course, actually is on the surface, out in the suburbs of London. And it's an interesting linkage. There's many interchange stations where you have to travel down escalators or use lifts to connect between different levels of lines. So it's a very challenging 3D space here on London's Underground.
The tunnels that were dug 150 years ago are still in operation today. The achievements of the Victorian engineers who built them have changed the face of the city. Not just London, but cities all over the world. The subway has become one of those places where a city really shows its character. In Paris, it's an Art Nouveau thing of beauty. In Tokyo, it's a million people moving in flawless unison. In New York City, it's the canvas for the hip-hop underground. Represent. And in Montreal, it became a showpiece for art and architecture. Hey, it's Montreal. You gotta look good.
Montreal is quite well known for the architecture in its metro. It's one of the best examples of modernist architecture, whereby each station was designed by a different architect, and whereby all the stations were planned to have artworks integrated into them. Berry-UQAM station is the heart of the network, and there are a number of important artworks there. The largest is a homage to the founders of Montreal. There's a couple of large oil and canvas works. They were from Expo 67. My favorite is Acadie Metro. It's got sections of hot pink, black, bright blue, and sort of this really interesting sort of high contrast look to it. Monk Station, that's in the Sud-Ouest borough of Montreal. It's got 2 gorgeous sculptures of 2 workers called pic et pelle. Travailler au pic et la pelle is a Quebec expression meaning to work long and hard. And they commemorate the workers who built the metro.
In Montreal, the metro isn't just a way to get between points of interest. It is a point of interest. The name Metro came from the Metropolitan Railway Company, the private business that built the first underground line in London. At the turn of the century, the Metropolitan Railway started putting up new stations out in the middle of nowhere, buying up the property near the tracks and then advertising it as a wonderful place to live. It was the invention of suburbia.
The Underground reached here, Finchley Road, in the 1860s. And at the time, there was nothing here. There was a farm, a couple of outbuildings, but really no housing.
They coined the term Metroland in the 1920s as a marketing slogan to entice people to move out to new suburban homes. And it's a name that's stuck.
People needed to be sold a dream, and they were sold the Metroland dream. They were sold the idea that here they could live in nice semi-detached houses that have their own kitchens, their own bathrooms, that even have central heating, which at the time was kind of very rare, and they would use the Underground every day to get to and from work.
Suburbia. What a wonderful invention. North America was very popular too. But here, suburbia was built by the motor car.
Without sprawl, cities would be much denser. They'd be able to support many more services. A lot of people do like cities, but in effect, they're forced out by policies of government that artificially cheapen land outside cities. Land is cheapened outside cities by discounted roads, often free roads, and electricity service is subsidized in the countryside. All the utilities, in effect, are subsidized outside urban centers.
It was the automobile that created the suburbs, but it's going to be the subway that tames them. As we begin to intensify as a city, and the official plan is built around the intensification of the city, and the key to that whole thing is the transit system, you'll find that it's absolutely necessary to extend good public transit out into the suburban areas so they can intensify.
Just a couple of miles beyond where the subway line now ends lies York University. At the moment, the students have a long, awkward bus ride to get there. But there's talk of extending the subway line. It will cost $1.5 billion. Is it worth it? No. They're young, they're only in school a few years, they should walk.
The truth of the matter is you don't build subways for 5 or 6 or 10 years. Building a subway is like planting a tree. It's having a long-term vision. You don't build it for the immediate city, you build it for the future of the city.
In 1918, they built a viaduct across the Don River. They built in space for a subway that wouldn't actually be there for another 44 years. Boy, they were pretty smart back in 1918. Wonder if anyone's that smart now.
Well, my ride is done, and it's been quite an undertaking. It's taken me 150 years to get here.
But the ride is not over. There's still 903,999 other people who have to get where they're going.
So you go, subway train. Get them there. Get on out. Ride in peace, my friends. Ole!